Let's use differentiation to find the equation of a tangent at a given x coordinate. So a quick reminder, a tangent is a line which has the same gradient as a curve at a single point. So in order to find the equation of that straight line there, we're going to need a coordinate. At what point does it touch the curve? And also a gradient. What is the gradient of that curve at that point? So 2 bits of information to find for this question. First of all, let's find the y coordinate. As we know x, we can just substitute that in to find y. Y is going to be 4 times the square root of 4 minus 2, which is just 0. So our coordinate is 4, 0. Now we need to differentiate, but before we can differentiate this, we need to simplify it into index form. So remembering that the square root of x means x to the half, x times x to the half, we add the powers to get x to the 3 over 2, and then we're going to have minus 2 lots of x just to the 1. Okay, now that's in a form we can differentiate. We can find dy dx times by the power, reduce the power by 1, and then times by the power, reduce the power by 1. We'll just be left with 2 because that has a power of 1 there. Okay, so we know that at x equals 4, if we substitute in x equals 4, it will give us the gradient of this curve at that point. So substituting x equals 4 into our derivative gives us our gradient of the tangent. So I'm going to call this m, 3 over 2, 4 to the half, minus 2. 4 to the half means the square root of 4, so 2 divided by 2 leaves me with 3 minus 2, which is 1. So we have a gradient of 1. Let's find the equation of this curve. So we know that we have y minus 0 is equal to the gradient, m, which we know is 1, x minus 4. Expanding this simply gives me y is x minus 4. So the tangent to this curve at that point 4, 0 will simply be y equals x minus 4. Okay, let's have a look at that with a slightly more difficult function, or at least slightly more difficult gradient. So let's say that we had y equals 3x cubed minus x squared at the point x equals 2. Okay, so same idea again. We don't need to simplify this one, so we'll just jump straight into the question. First of all, find the y coordinate. That's 8 times 3 is 24 minus 4. So we have a y coordinate of 20. Now find the gradient. So differentiate, times by the power, reduce the power by 1, times by the power, reduce the power by 1. Substitute in our x coordinate. Four times 9 is 36, minus 4 gives us 32 as our gradient. Y minus the y coordinate is equal to the gradient times our change in x. Simplifying this out gives me y is equal to 32x. That's minus 64 plus 20 is minus 44. I have the equation of my line, y equals 32x minus 44, and that's the equation of my tangent. Try some of the other questions and remember to use the GeoGebra file to see what it looks like and to check your solutions.